Hello there, guys. So, I was thinking, why not be a little ambitious? We're gonna try and do a medium heap question. Yeah, a fucking medium. Let's hopefully not get fucked over. Um, but let's go about this. So, let's read the problem. K closest points to origin. You are given a 2D array points where points I is equal to xi, yi represents the coordinates of a point on an xy axis. Okay, it's a coordinate basically. You are also given an integer k. Return k closest points to the origin. Okay, and this is how you define the square root. You may return the answer in any order. Okay. All right. Okay, let's think about this, okay? So we want to return the k max. Okay, so immediately what comes to mind is instead of keeping an array, instead of keeping a heap of size points, we can just create a heap of size k, max heap, or even a min heap, because we want to get rid of like the lowest, like the furthest. Oh wait, that's true. So the closer it is, the better. So if anything, it should be a max heap. No? Because we want to pop the furthest distance away. Yes. So we're going to create a max heap of size k and then pop, yeah, a max heap of size k and pop furthest one away. Now, the question is, how do we keep track of, okay, say we get the distance, put it in the array, we put it in the heap, that's all hunky-dory, but now, how do we correspond the distance with the origin? Like, how do we know it's this point exactly? Okay, so we do want to return k equals 2, okay? How would we relate the distance with that, though? Well, I'm thinking we could create like an hashMap with the distance of each bullet, like with the key being the distance and the value being the points that correspond to that distance. And then, when we do pop something, when we do get, a value at the very end, which is k, we can just return those values. And even if we make the size of the max heap k, we might have like more than k. That should be fine though, because it's gonna be like the largest k anyways. We're gonna check the length at every point, if that makes sense. So first draft, let's try and write this out. So we're gonna create a max heap. We're gonna create let me just talk to square root in Python, because I do not know how to do this. Math.square root, okay. Alright, math.square root. Right? Yeah. Okay. So anyways, we're gonna create a dictionary or hashMap of the coordinates. Key is the distance, val is the coordinate. Now, for point in points, it's gonna be like this. Point O. What we gotta use this basically. So point point O. Bro, okay, wait. My maths is so bad. Okay, point O minus 0. Point O. That's fine because it's 0. And then we can square root this, right? Okay, it's this one. And this is the y. It doesn't matter what value it is, positive or negative, because it's just going to cancel each other out. Let me write this better. So point square 2 math dot square root. This is the distance basically. Okay, nice. So now we have the distance. hashMap distance is equal to. I should do a default get.list actually. hashMap, so it initialize everything as a list initially, and we can just append the points, the coordinates. So distance is equal to nice. And we have to append actually. Sorry. Now I should probably create. I should probably just append first to the max heap. Okay, so that's gonna add in everything. Shouldn't I do like hashMap dot, just hashMap dot items? Oops, sorry. I'm pretty sure it's just dot keys. And then heapq dot heapify max heap while len max heap is greater than or equal to k. Greater than k. It has to be k exactly. So max, we can then q dot heap top max heap. It should be negative values. Right. Dang. Okay, so distance for distance and this should be a negative value because remember we want a max heap. So we're gonna be popping the furthest ones away basically. Yeah, so they're not gonna be here and it's just gonna be max heap. So let me just move this here for more clarity. And now we basically have everything. So my question is, how do we get the values? Because it's the top two, and a key may have more than one. Or should I just put 2? Append point. We can append 2. So it's going to be 2. Or should I use a min-heap, actually? Should I use a min-heap, bro? No, because if I use a min-heap, I'm going to be popping the closest one, which is not what I do. It has to be a max-heap. But I'm wondering if this approach here of, I'm kind of like grouping the distances together into one thing. Should I do this? Because now I don't know how I can access this. So res is an empty array. For, I don't know how I can, for I in range, len max-heap. -1, -1, -1. Max-heap. For point in max-heap. I don't know if I can traverse a max-heap the same way I traverse a list, so that's why I'm just doing this. If len res is indicated res. I think it's gonna get wrong. Okay. Float object is not iterable. Why is it a float object? Oh, because it's distance, right? For distance, basically. What? Oh my god, I'm so sorry about that. For distance in hashMap, I. Res.append point. Oh no. Okay, my output is none, bro. Alright, first of all, I just want to know. Let's do a little bit of debugging right now, because I'm not quite sure what's going on here. Let's return max-heap. And let's print out hashMap as well, actually. Okay. I think this makes sense. So the distance of 2 and 2.8, whatever. The max-heap has -2 because k is 1, right? Yes, so for I in range len, can this work? Len max-heap. Oh, should be max-heap I. So distance is equal to max-heap I. So now hashMap distance. Now this is the part because I'm not sure if this is actually possible. No. Distance is -2. for point in hashMap distance. Why though? Oh, right. It's because I made it a max heap, a negative value. This should do it. Oh my god, dude. Oh my goodness. Right. Dude, actually? Oh my god, dude, that's actually crazy. I'm getting kind of better at this. I did not expect this to take as little time as it did. 50 minutes, not bad. Time efficiency, let's walk through it. So this is O of n for now, just like going through the points. This is also O of n, just heapifying it. This is O of log k, yeah, where k is the size of max heap. So far it's still O of n, and this might be it. So I mean, I already have the max heap, so I think this has a time complexity of O of n, just because of the this part right here where I create a hash map of the distance and everything. And the space complexity would be should be O of n. O of n because we're keeping the distance and the coordinates right here in this the hash map. Yeah, like the heap has like a space complexity of O of k, but it's less than this, so we have to use that. So in the end, time complexity is O of n. Space, just time space. Space is, I think, O of n as well. O of n log k. Quick select. This is the solution I had. N log k. Why is it n log k? Min-heap. What? What? Wait, what is this time complexity, bro? Sorry, I'm gonna have to use GPT for this, bro. I do not know. N log k. N log n. What? Step 3. N log n. K log n. N log n. What? Why is it n log n? Oh, this might be inefficient. I got this, but this might be like the worst solution, bro. Oh no. Oh no. Wait, this is basically what I did, no? Okay. Huh. Alright, so it seems like, okay, I don't think it's this quick select solution. It's probably this, right? It looks like this like the way NeetCode does it, they don't even create a hash map to keep track of the distance related to the coordinate like I did. This is wrong roads and log n. Instead they did this, where, I mean, I'm glad I'm able to solve this though, but for xy in points. So it looks like they just immediately push it. Oh, they push everything at once. Okay. This is possible? What? Pooping. When it's popping, how does it know what is the maximum? Does it assume, since it's fed a list, a value? That's my question, because like, was it looking at distance, the very first value? How would I know that, dude? The first item? What? Dude, I did not know that, man. I did not know a dictionary of a heap could do that. Dude, that makes it so much easier because now I don't even need. I can just store everything there. Okay, I'm gonna just do that in that case. Just gonna rewrite this function. Yeah, we make heap. Yes, distance is equal to 4x, y. Points is something that's better actually. Distance is equal to negative x to x 2 plus y 2 and math dot square root, right? So max-heap dot and add a little. I guess you don't really need to square root it. Like it's the same thing, right? But yeah, screw it, bro. Q dot push. I guess I don't need to initialize a heap as well. So key pointers right now. Heap, you can feed it like a list and it will check the first item. I did not know this. I thought it can only take in a value. Very important information. Second key point, you don't need to initialize like a value. You can just push, like make a normal array and just push things into it with the heapq heap push function. I don't need to heapify. That just does it automatically, but you don't need to do that. So anyways, distance y equals y. And then yes, if len max heap is greater than k, we pop heapq dot heap pop max heap, basically. Now we just build the answer, dude. Just keep popping until we get the damn answer. That's so easy. And like, also another key point is I can like break this down too. I don't need to do like 4 point endpoints because then it's just 0.0, 0.1. Yeah, it's the same thing, but this just makes it more readable. So this I think is a way better solution because I'm just like straight up heapifying it. So this is like O of n. This is like log of k basically. So n log k, this whole operation right here. And that's basically the thing that matters. Like this is like log k, who cares, right? So in the end it's n log k, yes. Time is O of n log k. Space is O of basically k, right? The heap. Yep, exactly. Wonderful. This is a much better solution. All right. right. I mean, this isn't a bad solution. I just wasn't aware that I could do certain things with a heap. So now that I know, that is really good. That's that.